Recording. Okay, so good morning. I'm Aadit Kamat and I'll be presenting the Intermediate Java workshop. This is built upon the Introductory Java workshop that was conducted by Julia. So let's start off with a recap of the concepts covered. So Java programs generally consist of classes, with each class having its own method or more than one methods. And the convention is that you declare each public class in its own file, and the file must have the same name as the class. So for example, uh, let's look at the comments.java file. In this case, the name of the file is comments.java, and the name of the class, which is declared as public, is comments. Generally, Java programs consist of a runner class, and the runner class is the class that must be executed. So the runner class has a main method, which usually has a signature public static void main, and it takes in a string array of arguments. So in this case, as you can see, you have the same signature, and hence comments is a driver class or a runner class. How are Java programs executed? So you have the source files with the .java extension, which are then compiled into Java class files before they're executed to run the program. Another thing to take note is that variables used in Java programs are generally in camel case, which means that the first letter of the first word is in lowercase, while the first letter of the subsequent words are in uppercase. On the other hand, the constants are consisting of all uppercase characters, and they're declared with the final modifier. You can see an example over here where you have an integer variable, and this is in camel case because, as you can see, the first letter of the first word is in lowercase and the first letter of the next word is in uppercase. And this, on the other hand, is a constant. And so constants are in uppercase and they're declared with the final modifier. Yes, so when we are talking about variables, it means that we can modify the contents of a variable. So this is perfectly allowed. What this means is that it is adding the value 5 to the existing contents of the integer variable, which in this case is 3. On the other hand, since constants, as the name suggests, are supposed to not vary in value, you cannot do this. You cannot modify the contents of a constant. So we can just run this program to demonstrate this. Let's say we compile the variables and constants Java file. As you can see, this line number 6 reports an error because we are not allowed to modify the value of a constant. Another thing is that the static modifier is used for methods and fields that should be accessed at a class level and not at an object level. We can see this in this example program.
What is the difference between class level and object level?
Okay, so basically, the class level means that, as you can see over here, we are accessing using the class name and followed by the field name. Whereas when we are talking about at an object level, we are instantiating the class and to create an object and then accessing the field or the method. I hope that clarifies. Okay, in that case, I'll move on.
You broke up for a minute. Can you repeat that?
Okay, sorry. So basically what I was trying to say is when we are talking about accessing at a class level, it means that we are using the class name as in over here and then accessing the field. Uh, whereas when we're talking about object level, we are instantiating the class to create an object and then accessing the field or method, whichever is declared as static. Is that clear?
And can you also explain the difference between final integer and integer?
Okay, so this was over here, right? If you did not put the final modifier, then this would basically be a variable and you're allowed to modify it. So you can see that over here.
Oh, okay, thank you.
Yeah, but then in this case, the convention is for constants to be uh, and the constant name to have all uppercase characters. All right. Now I'll move on to explain the primitive data types. So these are basically the kinds of primitive data types you would see in most Java programs. And for integer like primitive data types, basically how you get the range of values that can be represented is by using this formula. You look at its size. For example, for byte data type, it's 1 byte, as the name suggests. And as you would know, 1 byte is equal to 8 bits. So the lowest number in the range is minus 2 to the power of 7. And 7 is 1 lesser than 8. Whereas the upper bound is 2 to the power of 7, which is 128 minus 1. Um, for um, for double or float, which are used to represent values with decimal points, the system works differently, but you can see that roughly doubling the size also increases the number of decimal digits that can be stored by a double. Now I'll move on to explain access specifiers. So access specifiers is basically used to refer to the visibility for the different data members, which includes both fields and methods. So uh, public declared data members can be accessed by all classes and objects. Whereas when you have protected data members, they can be accessed only by the current class, the child classes, as well as the nested classes and their objects. Private data members, on the other hand, can be accessed only by the current class as well as nested classes and their objects. And I'll cover what are child classes and nested classes in the subsequent slides. Now let's move on to talk about inheritance. Inheritance is basically an important concept in object-oriented programming. And as Java is an object-oriented programming language, you can see this concept being used extensively within the language. What does inheritance basically refer to? It's talking about passing down properties, fields, and methods from the parent class to the child class. The child class can basically either use the properties as or override them. And inheritance is arises as a concept basically to mimic societies where inheritance is passed down from one generation to another, which is the case for a lot of living organisms. And inheritance comes in handy when you are trying to model hierarchies which have a is a relationship. So I'll clarify this by using an example. Let's have a look at this folder. Um, so you have the animal class, which is in this case is the parent class. You have the mammal class, which is a child class of the animal class, and you have the human class, which is the child class of mammal. So basically, this is used to model the hierarchy that a human is a mammal and a mammal is an animal. So let's see how the program works. So you have the animal class with a private property and a protected property. And use this to show, I'll use this to demonstrate the public, protected and private access specifiers. Let's say animal has two methods, eat and speak. And in eat, you're basically printing out animal eats, and speak, you're printing out animal speaks. This is a very simple program. Uh, when you look at the child class for this animal class, uh, you see the two methods again, eat and speak. But in this case, they are calling the super method, which means that they are calling the eat method of the super class or the parent class. And after doing that, they're basically overriding the behavior of the original parent class's method. So in this case, you're trying to not only invoke the eat method for the parent class, but you're also printing out the value of a protected property, and also printing out a string mammal eats. It's a similar case for speak, but we have not printed out anything. So this is just an example to demonstrate the concept. Yeah. In this case, we are allowed to print this out because protected data members, as I mentioned, can be inherited by the child class as well. Let's let's try and execute this to see how it works. Inheritance. Okay, and let's say we okay, and actually we will be using the driver class, which in this case has the same signature, to demonstrate how the classes are instantiated into objects and how the object methods are called. So yeah, one final thing I also wanted to show about is the human class, where you have the eat method, and it's also calling the super classes eat method. And this is just an example to show you that you're not allowed to print a private property, because that is restricted only within the class itself or its nested classes. Um, so, and it does a similar thing here. It overrides the behavior of the parent class, and implements its own like functionality as well. So when you look at the driver class, what it's doing is it's instantiating three objects, one animal, one mammal, and one human, and then calling the eat and speak method for each of these objects. So now with this knowledge, let's see how this works. Okay, so when you're calling the animal dot eat and animal dot speak, you're basically getting animal eats and animal speaks, sorry, as you would expect. But when you call mammal dot eat and mammal dot speak, then the behavior is slightly different. You first call the super classes eat method, so it prints out animal eats. It prints out 5 because in this case, as I've shown, we are printing out the protected property, and then we are printing out mammal eats. It's a similar case for mammal speaks, because mammal is also an animal. But we have, the only thing that's different is that we are not printing out any value for the protected property or the private property. Then when you look at human.eat and human.speak, it not only calls the animal dot eat and the mammal dot eat, but also the overridden human dot eat. So basically what happens is that you have a parent class, and the parent class is parent class, and you're calling those methods accordingly. So that's how the inheritance works. It is passing down from parent to child and to its child as well. And yeah, basically, yeah, this example is used to demonstrate inheritance. Hope this is clear.
Just a quick question, where does the 5, which was printed, come from?
So okay, so the 5 actually comes from here, system dot out the print line super the protected property, and the value as we have set here is 5. This is just to demonstrate that the protected properties can be passed down to the child class, whereas private properties and methods cannot be passed down. So if you were to, let's say, like comment this out, and this you should get an error. Sorry. Oh, okay. Sorry. It's compiling the wrong file. Okay, yeah. So as I mentioned, it's not allowed because it has private access in animal. Okay. So then if this is clear, then I can move on to the next concept, which is nested classes. Okay. So nested classes can occur at multiple levels. So you can generally have one or more classes nested within one class, and then classes that are nested within the inner class as well, and this can go on. Generally, though, it's more used like in programs that might use nested classes. They are generally nested only up to one level. And the nice thing about nested classes is that the inner class can access the members of the outer class and modify as necessary. So these properties, I mean, these members can be public, protected, private, static, or non-static. And sorry, the inner class object can be instantiated only once. That once the outer class object has been instantiated.
What
So,
does it mean as static and non-static?
okay, so static and non-static, let me go back to the earlier slide. Yeah, so the static modifier is basically used for fields and methods that should be accessed at a class level and not at an object level. So when we're talking about non-static, it means that we are not using the static keyword. And this means that these are object-related methods. Okay, so let me actually show the nested classes with an example just to make things clear as well. Let's go back to nested classes. Okay. Yeah, so there is this class which I've called outer, and it has an inner class within it, which has some method. And in this case, I've used public static int to show a static variable that's public. And this just demonstrates how the inner class object can actually like access all these types of fields. So in this case, what the method is doing, I've called a method, is that it's printing out the x, y, and z values, and it's instantiating the outer class object. So this is the driver class or the runner class for this program. And let me execute it to show you the behavior. Okay. All right. So basically what I did here was again create an outer class object and then modify the x variable, which is over here, and then call the inner sorry, yeah, and then instantiate the inner class object before calling its method. So once it does that, then it goes to, yeah, it will print out the modifier value of x, which is 3. And then it will also print out 4 and 5. And the, as I mentioned earlier, the outer class object can be instantiated only once the inner class has been instantiated. Okay, so this, let's see, yeah, actually this line is not required. Okay, so the next concept after this that I'll be covering is interfaces. Interfaces are basically used to specify the methods that need to be implemented by the class, which is why you don't have the implementation of the method specified in an interface. An interface usually serves as a contract between the class and the outside world. And this is a contract which is enforced during the build time by the compiler. What this means is that, let's say you have a class that implements an interface, and it does not implement all the methods in that interface. In that case, the compiler will flag this out as an error. One exception, though, is by declaring the methods in the interface with the default keyword. Those usually have their implementation specified. But you would only want to use this if you want to have classes to have methods that need to be already implemented. So this depends on the use case. Let me demonstrate interfaces with an example as well. Um, let's say we have an interface called communication device, and it consists of two methods: send message from sender to receiver, and receive message from the receiver to the sender. And these are declared with the type void. So because you see how it's going to be implemented by the mobile class. So this is the syntax for how a class implements an interface. The implement keyword is used, and as let's say this is the method that needs to be implemented. So when you go to the mobile class, then you have this print statement. You're printing out the senders sent some message to the receiver, and when you're implementing the receive message, then you'd say receiver received from the sender. And then we have the driver class, which basically demonstrates this. You have a, an object which is an object variable called cd, which is declared of the interface type communication device, and but is instantiated using the mobile class. And this is something that's allowed because a mobile is a class that implements the communication device interface. Then after that, on the object, we are calling the send message and the receive message methods. So let's run this to see how it works. See. Okay, so yeah, it basically prints out 1 sent to 2 and 2 received from 1, as per the implementation specified in the mobile class. If that's clear, then I can move on to the next concept. Okay. So now I'll talk about abstract classes. And the reason why I'm talking about abstract classes is because they're actually quite similar to interfaces. You can specify methods that are not implemented using the abstract keyword instead of um, how they're specified in the interfaces without the abstract keyword. But you can also have methods that are already implemented, just as in interface with the default keyword. But in the case of the abstract classes, then you don't use the default keyword. Yeah. So, but as you can see, there's also some differences between interfaces and the abstract classes, and these are the main ones. So in abstract classes, you can have data members that are public, protected, or private. Whereas in interfaces, you have the fields that must be public, static, and final. So you could say the sort of the signature of the fields. Whereas the methods are public by default. Um, And with abstract classes, since multiple inheritance is not allowed for a in Java, which means that like a child class cannot inherit from multiple parent classes. You can have only the child extending one abstract parent class. Whereas for interfaces, a class can basically implement multiple interfaces. Okay, with these two, I think, yeah, sorry. Yeah. There's an example for abstract classes as well. Yeah. Um, so let's say we have the class circle. And so actually, yeah. Let's say we have the class shape. We have declared this as an abstract class because a shape is, yeah, we would only know, say, that it has an area, but we would not know any other attributes for that uh, shape class. Like, what does a shape object actually behave like? But when we look at classes that extend from this shape class, then we get some idea. So, for example, for a circle, um, you basically have a radius, and then you have the area method, which is implementing this formula pi r square. Whereas for a rectangle, you have a length and width, and the area method is implemented as length times width. So in this case, with the driver class, we can demonstrate the concept of abstract classes. Let's say we go to abstract classes. Okay, and let's see. Um, Yeah, so yeah, the circle area is implemented accordingly, and the rectangle area is also implemented as per the formula. Okay. Um, so let me go over the other concepts as well. Like for we also have data structures, and these common data structures can be found in the java.util collections package. So these are the main kinds of data structures you're likely to encounter in Java. The list interface with implementing classes, array list, and linked list. And these are used to store a number of objects in a particular order. Whereas when you look at set, basically a set is used to refer to a collection of objects that are stored in no particular order. And a class that implements it is called hash set. And then you have a map interface, and that's used for storing key value pairs, where you're mapping objects of one type, keys, to objects of another type. And the type of the keys and values can be the same type. An example of a class implementing map interface is hash map. So basically, as you'd say, in this case, you have EKV, and these are basically known as type variables. This invokes a concept called generics. And this comes about because we need to have containers that must be they often need to be homogeneous, which means that they hold objects of the same type. Um, and in this case, when you're looking at this, then this is the type variable, and the the variable can hold either like an integer, boolean, string, or any other data type. It's the same thing with set. When you look at map, you have these two type variables because the key and value, they may either be of the same type or different type. Yeah, so like in order to use type variables, you need to have classes for the raw data types like integer, boolean, and because character, because um, otherwise you cannot uh, just plug in the raw type into this type variable, because it's expecting some object, uh, like some data type that extends from object. And basically, the objects that are created from these classes, they are acting as wrappers for the primitive values. Um, so basically, it's like and you can have a object, an integer object, and then it wraps around the integer value. And it's useful for specifying the type variable, which I mentioned earlier. Next, I'll be covering about functional programming. And basically, with Java 8, there's support for functional programming with the introduction of streams. So some of the useful classes are found in the java.util.stream and the java.util.function packages. Okay, so in functional programming, for example, you have these kind of interfaces which are found in these packages. You have the stream interface, and this is used to create a lazily evaluated collection of objects, which are of the type E. What do you mean by lazily evaluated collection is that the objects are not created immediately, and but they're created only when some evaluation needs to happen, some computation needs to happen. And that's why it's useful for representing an infinite number of values in theory. But when you're actually calling some methods on streams which need to do the computation, then it will uh, basically create the object and have only a finite number of values. Then you have other interfaces for different kinds of functions. Uh, for a function that takes in a parameter of type E and returns a result of type R, you have the function interface. Then you have a consumer interface for a function that takes in a parameter of type E and it does not return a value. Then you have a predicate interface for a function that takes in a parameter of type E and returns a Boolean value, which is based on testing the parameter. And then you also have supplier interface, which is used to represent a function that does not take in any parameter, but returns or supplies a value of E type. And then finally, I've also mentioned the optional class, which is in the java.util package. And this acts as a wrapper around a value that can be null or non-null. If you're familiar with JavaScript, the syntax for functional programming in Java is similar, where you're having arrow functions for specifying the input parameters and an output. Um, The idea behind functional programming is to make use of pure functions as far as possible. You have to take in some inputs and return an output solely based on the inputs, with no side effects which modify the inputs. Okay. Now I'll move on to asynchronous programming. And in most programs you write in Java, they will be synchronous, which means that the lines of instruction or the code execute sequentially, which means that the second line is executed after the first and so on until the end of the function. But Java also allows you to create asynchronous programs where you're executing some blocks of code independent of others. And the nice thing about it is that the execution does not affect the overall program's behavior. So there's basically two types of asynchronous execution. One is parallel, where you have blocks of code executed at the same time by different threads, which means that they run at the same time. But when you're talking about concurrent execution, the threads are actually switching back and forth between blocks of code in different unit time, like time units. And when this is done fast enough, which most modern operating systems do, then it gives you the impression as though the blocks of code are being executed in parallel, but actually they are being executed at different time units. What are the classes and interfaces that you can use for asynchronous programming in Java? So the interface is called future, and it's basically used to represent the result of any asynchronous computation. You're fetching the result only once the computation is done, and until then you're gonna block the the method. And then you have the completable future class, which implements this interface, and it is used to represent a future that may be explicitly completed. So I'll demonstrate the concept of asynchronous programming with an example. So let's say you have this AP class, which is short form for asynchronous programming. Basically, it is creating two objects of supplier interface, and yeah, this is basically used to um, take take in this is basically used to represent a function that takes in no parameter and returns a value of string type. So in this case, it's hello and world. And then I have another function or a by function which takes in two strings and concatenates them together. Now what I'm doing in this line of code is to create a future uh, based on the first supplier function, and the next one creates a future based on the second supplier function. Then you have a combined future, which is formed by taking the first future object and calling the then combine uh, with the parameters as the second future object and the uh, concatenate function. And then I'm printing once the combined completable future is completed. So I've also added some values in the catch block because you're likely to get two exceptions. One is if the execution is interrupted at some point, and the other is if the execution itself results in some error. So let's say we run this class. The result is hello world. Because in this case we are executing all of these lines of code successfully. So um, what happens is you have one future with this supplier and the second future with this supplier, and when you're combining them, um, which means that these functions are executed asynchronously. So the first one may be executed before the second one, um, or the second one may be executed before the first one. Um, but what we are doing here is that we are actually combining and then printing the results. So it will wait for, even if the second one is executed first, it will wait for the first one to execute and then it will combine the results. So you would still get these in order, where you have the hello executed before the word, and then concatenate it together with it. So that's all for this presentation. These are some of the websites I referred to prepare for this presentation. That's all from me. Thank you.